Can you guys see my screen?
Yep.
Cool. So this is Intro to Backend Testing. We're going to cover the Go testing package, Testify, and a couple other things related to testing. So yeah, table of contents. We're going to cover Go testing. We're going to cover testing loops and should assertions, defer and test cleanups, Testify, unit tests versus integration tests, and testing on the job when you get to Twitch. So the basics of testing in Go. Go comes built in with a testing library. So the command to run that is just go test in your terminal whenever you have tests built out. All the tests in Go have to be prefaced with a test and then whatever the method name is. And then Go automatically picks those up whenever you run the testing suite. And the core bread and butter of testing in Go is testing.t. This allows you to run t.run for all of your actual logic in your tests, t.error for actually printing out error statements in your testing console, and just really everything related to testing happens in testing.t. Go also does have a testing.b. I have never used it. We don't use it at Twitter. We don't use it anywhere else. It's for benchmarking tests and benchmarking your logic. But realistically, when you work in a production environment, they'll have infrastructure set up for you to actually set metrics and counters and timers within your code so that you can view it in a separate like registrar tool so that when you're running code in production and say you build an API, you'll actually refer to registrar to see your call stack and to see all of these different metrics line up with how long it took to execute a single code block so you know where you need to optimize further on. And t.skip. We're going to cover this a little bit later, but in production, when you're working on a large code base with a lot of people and you're constantly adding and building new services, tests can become flaky over time. What is a flaky test? So flaky tests involve anything dealing with like you're merging in new code and suddenly your AWS builds start failing. But your logic works in your local tests and it works in production. It's just the testing suite itself is starting to not recognize certain tests as viable logic, if that makes sense. So either in that case, you will want to actually dig down into the logs and actually fix the test. A lot of the times in Go, tests become flaky when they have concurrency in them. And the testing suite doesn't always handle concurrency consistently across iterations. So you'll have to go in and fix that. But alternatively, you can add in a t.skip flag onto the method. And so what t.skip does is it tells the Go compiler at runtime when you're testing the suite to skip over this test and continue on. We use this at Twitter a lot when we depreciate old services. So like Fleets was a service that we depreciated, but it still has tests in there for parts of the service that we still use. But some of the tests aren't relevant anymore. So rather than remove them altogether, we had a t.skip flag, and then we're able to continue on. So advanced testing in Go, you can use loops a lot of the time. So just an example right here, I built a compare method. This compare takes the two inputs, compares them together, returns true or false. And then now I have a test class. So it's prefaced with that capitalized T, test. So the testing suite will pick it up, testing.t. And what you can do in Go, instead of having to write a separate t.run method for every single time you want to test logic, if your logic can be condensed into one method, you can actually like create a for loop where you actually add in your separate names, your inputs, your expected results, and actually change them dynamically in one line and have the same logic run over and over with different inputs to make sure you're covering a full suite of all the failure cases, all the accept cases, and everything in between to make sure you have really well-rounded tests for your code. And defer and clean up. So at Twitter, we have these things called dyn vars. You might have something called differently at Twitch, but basically these are variables that we can set in our code that are stored also in Dynamo in AWS. And so we can change them on the fly while code is still running. And so say you're building a feature in production and you want the ability to turn on and off in case it starts creating panics in production. So you wrap it with a Boolean wrapper and just say, if this flag is enabled, execute the code. Or if it's not enabled, don't execute the code and skip over it. And so that would be a dyn var where you actually set that Boolean value in Dynamo so that at any given point in time, you can go in your terminal, flip the flag, and execute logic accordingly. And so what happens is that when you're running your testing suite, it's picking up the most current value of that variable. And so if you have a flag turned on or off, and the test is expecting that flag to be the other version, it's going to start failing. And so rather than creating new flaky tests, we're going to add this defer method. And defer is going to actually statically set that value. No matter what you change it to, it'll always be set to that value. So your core logic can be tested the same way every time, and you're good to go. T.cleanup. T.cleanup is something we use occasionally. So at Twitter, we have our Dynamo database and any other sort of tertiary services that we use to build out our tests and test our logic thoroughly. T.cleanup is something we add in at the very start so that we can start adding in new variables and new objects into our databases and not have to worry about affecting our production services. So what T.cleanup does is you set it at the beginning, defer it, and then as your code executes and you're adding in these new objects, T.cleanup is part of the Go testing suite. So it'll know that, okay, these objects are created during the testing suite, but they're not always needed. So at the end, we're going to go ahead and clean up the data, clear the Dynamo tables, and just get it out of the way so it's not actually affecting production code. And now Testify. We do not use this at Twitter, and I have never used Testify. So this is largely from the documentation. So Testify works very similarly to should assertions, which is what we saw before, where I can go back, where you'll see at the bottom here, this is that testutil.so and should.equal. These are from the should package. It's just a bunch of very basic equivalents, not nil, should resemble, all of these different comparators between the objects passed in to help you run your tests and make sure things are running as expected. Testify kind of does a similar thing, but it gives you a little more flexibility in what it does, for better or for worse. Assertion works exactly the same. So it's assert dot not nil, assert dot equal, assert dot should resemble, and then you just pass in the objects after that, and it works the same way. It's a little less readable, but it does the job. Mock is a weird one. A lot of the times when you're working with external libraries, they'll have their own mocking functions. So in Python, there is this one service that I've contributed to called Modo. Python's AWS library is called Modo. So Modo is just a mock version of S3, Lambdas, Dynamo, and everything else in a package where you can run in your test, and it's a mock service. So it's not actually hitting AWS, but it's hitting the same call path as if it would, so that you're able to test your logic and make sure everything's working accordingly. Testify mock allows you to actually do a similar thing where you're creating these data flows ahead of time so that when they're used in your testing logic, it's calling those mocked objects and data flows so that you can test it accordingly. Suite kind of works in a similar way that the main testing libraries cleanup works, where that you can actually build up different components of your logic. You can build up setting initial values, and you can say spin up a database instance, and then it all works as its own isolated test suite of like sort of that object-oriented like inference and inheritance of different methods all across the isolated testing suite within your larger Go testing environment. And unit tests versus integration tests. Unit tests are going to be focused on testing your specific logic to ensure that, say, the method you write or any of the logic and data flows you write are working correctly. So that compare method we had in the example, that would be an example of a unit test. Integration tests, on the other hand, are something you're going to write. So basically between our GraphQL service and our actual service layer, where you're making sure that changes in either one aren't breaking the data flow overall. So they will probably, in the GraphQL side of things, be an integration test where it's actually testing, can I still fetch the logic from service? And does it all flow correctly to the GraphQL layer? And testing on the job. So at Twitter, we use GitHub. And so GitHub allows you to add these different GitHub actions and different elements to your PR testing suite. So a PR testing suite happens outside of the tests you write for your code. It happens when you commit and push your code to GitHub, and all of these different elements execute and actually test your most recent version of your PR. So these can be anything from like formatting your code to different AWS integrations to actually running it through your code deployment pipeline in a sort of dev environment to make sure that everything is lined up correctly so that when you do merge your code into the larger code base, you're pretty sure that nothing's going to break and fail, and you won't have to revert that merge. And as we mentioned earlier, tests will sometimes degrade over time, especially as you depreciate services or if concurrency fails or whatever. So you have flaky tests. Sometimes you skip them, and sometimes you actually go in and dig into the logs. We use code build at Twitter, and you sort of figure out what's happening and what's failing so that you can go in and actually fix that logic up so it stops being a flaky test. And now it's time for Q&A. So if anyone has any questions, I'm more than happy to answer them. Or we can call it there. Cool. Good to go. I will catch you guys at the backend sync. Thanks for joining my talk.
Thanks,
Thank you, Rachel.
All right, bye.